you've read the book. Hey guys, so we're just going to hit on this again since you didn't think you had an assignment. Well, there should have been one, but maybe not. That'll be okay. This should hopefully make some things clearer to you, and yesterday should have made things clearer to you. Day 2, we're going to do the definition of the derivative and do notation. These are for another day. Okay, the derivative gives us the value of the slope of the tangent line to a curve at any given point. So if I have a curve, and remember what we did, we drew this line cutting through the curve in 2 places. Do you remember what we called that? Secant. And as I would take a point here, make it bigger, I can only see it, and I'm going to drag this point down, and I'm going to draw that secant line. That's what you had to do for the first part of the lab, was just draw a bunch of those secant lines. And I gave you an example of how to do the calculations, which you didn't have to use my short way of doing it. And eventually, I want these points to get so close together that when you zoom in on this, what does it look like? A straight line. Because you can't find the slope between one point and itself. It doesn't make sense. So you have to get really close. Remember, we don't care what happens at that point. We want the limiting value. So the derivative is just the slope of this tangent line. That guy slid a little bit. Okay? That's all it is. That's what a derivative is. Why it's called a derivative, I have no idea. Derivative gives the value of the slope at the point on the line where the curve, the line's tangent. How many places does a tangent line intersect the curve? 1. How many tangent lines are there at any given point? 1. Okay? We do this all the time. We do average rates of change. Okay, guys? Good idea. Okay. What is a rate? A rate. See, that's key here. What is a rate? You guys do this in science. You can talk about the growth rate of bacteria. You can talk about exponential decay. A rate is a ratio. Okay, guys. A rate is a ratio. So when I'm looking at a rate of change of a function, it's the change in the y values divided by the change in the x values. That's important because you're looking to see that if you change the x value, what happens to the y value? Well, I'm going to draw a little sketch here. I like to go on trips out west. I love the west. And I drive. So, you know, here's my time, here's my position, and I might anywhere, Wyoming, Montana, Colorado. Okay, so I go at a constant rate for a while, but then I have to stop, right? And then I go at a constant rate, and I have to stop. It's probably not as smooth as that. And I can find my average speed by drawing the secant line. This is going to be on the exam. So your average rate of change, your average speed, because we can all understand that, is the total distance divided by the total time. Or if I drive to Chicago, just to make the math easy, it's about 400 miles. It's more than that. And let's say it takes me 8 hours to drive the 400 miles. What's my average speed? Yeah. So it's 50 miles per hour. As time changes, my position changes. So you have to talk about something as one thing changes, how something else changes. It's not enough just to talk about how the numerator changes. Okay, Molly? Focus here. You don't want to have to come back and watch the video again, right? I don't think so. That's my average speed. Now, if I'm driving to Chicago, am I driving 50 miles per hour all the time? No. Anybody know the speed limit in Wisconsin? No, I think it's 55 in Wisconsin. Yeah, because I've driven through Wisconsin a lot of times. That's low. If you go out to Montana, it's 75. Used to be no speed limit, which I didn't like. No, it isn't, because when you go around a curve and you're going 90, curve might not be able to handle 90, but you don't know that. So that's a problem. Okay. That's my average. Okay, guys? Average rate of change is simply slope that you learned in Algebra 1. That's all it is. It's just slope. If you can't see, let me know. I'll figure something out maybe. Now, your instantaneous rate of change is at an instant. So, if I'm driving to Chicago and I'm averaging 50 miles per hour, my speedometer is probably saying at least, well, it's going to say 50, for sure it will say 50 at least one point in time, but my instantaneous velocity is probably higher than that. So when I go out west, you know, I can go 75 miles per hour on the freeway, but I'm not going to average 75 because I have to stop, unfortunately. So your instantaneous rate of change is what you see in your speedometer. That's a derivative. And that's what we talked about yesterday. It's the limit. As h goes to 0, in fact, let me draw the picture. Here's A. I don't care if you call it A or C. This distance here, I'm going to call H. Okay? So this is A, comma, f of A. And this point here, what's my x-coordinate there? Right here. If this is A and I go over H units, this is at where? A plus H. So this ordered pair up here is A plus H, and my function is f, so it's f of A plus H. So my average rate of change in terms of this function is f of A plus H. It's the change in y. Whoops, wrote it wrong. Let me go to black, because I don't think you can see it back there. So it's f of A plus H. I want the average rate of change, so I want the change in the y values. So it's the change in this divided by the change in the x values, minus f of A all over A plus H minus A. You see slope there? Steve, do you see slope there? Yes. And then, what do I want for the instantaneous? What do I want to do with this point right here? I want to slide this down, and I want this point to get closer and closer. That's what you did in the lab. You zoomed in on it until it looked like a straight line. Then you could find the slope at that point. Pretty darn close. It's not exact, but it's close. So what's happening to H? What's happening? H is the distance between A and this x-coordinate here. What's happening to H? Good. Don't make it hard. H is going to 0. And I'm going to find the slope as this point gets closer to 0, so it's f of A plus H. This is an answer to one of your questions. Minus f of A all over A plus H minus A. I like to write it that way because I see slope here. But somebody said, can't I just do this? Yes, you can, but do you see slope anymore? And this is the way we do it in calculus classes. We use this form of the definition of a derivative. And they will show you another form, which is the one I use all the time in science classes. But this one, Noah, this one, I don't see slope there so easily. I do if I have it written like I do over here on the left, but not like that. But you're going to use that because that's the one you're most familiar with. And what is another name for it? It's a derivative, or this is your velocity. This is your speedometer. So when you drive your cars, and everybody's ridden in a car or a bus, that's the speedometer. So you're doing calculus when you drive your car. Yes. And there it is. The notation, we'll have multiple notations, but right now, for the moment, we're going to call it f prime of x. Now, this is at any point. X is any point on the curve. You're not going to like the algebra. Now, there's only two parts to calculus. And normally you get all of this done in one semester. We're going to take 2 semesters to do that. Differential calculus is what we're doing right now. It has to do with derivatives and integral. That's second semester. So when you get on the exam, you know you have to do some calculus. You're either going to find a derivative or you're going to find an antiderivative or an integral. That's it. Of course, it'll all be applications. So chapters 3 and 4 are all applications of the derivative. First, we have to figure out how to calculate them. And then they're used all over the place. So you'll see them in other fields. If you're going to become a biologist, you're talking about growth rate. If you're a physicist, for sure you use calculus. If you're an engineer, you use calculus. Even if you're in chemistry, you use calculus. Because you're talking about rates of change. Because when you collect data, you don't collect data about the function. You collect data about how the function changes as time changes. And I'll stress that a little bit more. Okay, that was the first one. If the derivative exists, we say the function has a derivative and it's differentiable. So do not ask me what differentiable means. It goes in your vocab. You need to know that. It means the derivative exists. So let's do the first problem here. And you had to do this for at least part of that lab. You had to find the derivative of x cubed. So I'm going to write out the formula. So it's the limit, and you have to be able to write it out. We're going to quiz you on that. Let's just do it at any point x. You could do a or c, but we're going to do x plus h minus f of x all over h. There's the calculus. And if you don't understand, ask, please stop me. So now what I'm going to do is put in x plus h in for x here and here. So I'm going to get the limit as h goes to 0, and it's x plus h cubed, right? And then I'm going to put in x into f of x, which is just f of x. So it's minus x cubed. And if you remember, I promised if I don't make a mistake there, a lot of stuff's going to cancel off. That's how I find out that I did things wrong. Okay, so we're going to come up here, and guess what we have to do? We have to cube that out. Do you remember how to do that? You had to do it in your lab. Remember, it was 1, 3, 3, 1. So it's going to be x cubed plus 3x squared times h. These exponents have to add the 3. Plus 3x h squared plus h cubed. See if I can slide that. A little bit. Okay, and then I'm going to do minus x cubed, and it's all over h. You can cube it on the calculator, but I want to see the work here. And what happens? What? Pardon? Because that's how you cube out x plus h cubed. You have to use these coefficients. You had to do this in your lab. That's Pascal's triangle. So that's what this is. This is the first part. Is it easy to miss a piece? Yes, because I did it in another class. What happens to x cubes? If I did it right, these will always go away. Now, can we go ahead and skip a step and just look at this and factor that numerator? Because what's a common factor there? Because I'm too lazy to write it all out. So it's h, and I'm left with 3x squared plus 3x h plus h squared all over h. You may reduce your fractions provided it's multiplication, which it is. So h goes into h once and once. Now for the calculus. This is the hard part. Substitute h equal to 0 in this and this one. Not in for x, just for h. So what happens to these two terms? You're going to plug in h going to 0. Remember, we always substitute. If h is 0, what happens to 3 times x times 0? That's 0. 0 squared is 0. So what's the answer? What's still left? 3x squared. That's it. Some of you are thinking there's probably got to be an easier way. Really? Yeah, there is actually. Because you had to do Oh, I didn't want to do that. Hang on. You had to do this. Yep. Just what you had to do for your lab. You had to do the sine of A plus B. And I don't know if my reserve yesterday gave you what the identity is. You could have looked it up. But you need the sine of A cosine B plus sine of B cosine of A. And one of them was, you're doing this at pi, I think. And so the sine of pi is what? What's the sine of pi? Yeah. It's in your lab. You had to expand the sine of pi plus h. And so the sine of pi is 0, so one of these terms is going to go away. So you might have time to fix that. Oh, I know what the shortcut is. Okay. There's another form for this definition. So I'm going to go ahead and draw it here, and then we'll do the square root. This is the one I like. And if I have a curve here, like this, and I'm going to have this be at A, and I'll do it right, and this is at X. And what I'm going to do is take this point at X and drag this down the curve. So I'm just changing how I name these points. That's really all I'm doing. So what's this point here? That's A, comma, F of A. And this one is a little easier, at least, to set up. X, comma, F of X. So what's the average rate of change? Well, it's just the slope of the secant line. That's all it is. It's just the slope there. Yeah, we've done this, right? It's F of X minus F of A over X minus A. We're going to do square root of X in a second. I'm just trying to get the alternate form, and I don't have any space. Okay. What am I going to do? If I drag this point down here to find the instantaneous one, if I can find it.
Wait, where do you get it?
What thing? It's just, I just renamed it, that's all.
Where? How?
Before we called that, where did I put it? Previous one? Before we called that, where's my picture? No, I must have done that on another slide. No. That one? No. Oh, it's right there. Remember how I did that? Oh, you can barely see the picture, but there it is. I called that A. Now, instead of calling this H, I'm calling my new point X. That's the only difference. It's just a different way of writing it. It's the same thing. Okay, now I want to find what? I want to find the instantaneous one. So how do you find the instantaneous? It's a limit. And what am I going to do with this green dot here? It's going to get closer and closer to, not 0, A. The distance here, which is H, that goes to 0. But I want this one as X approaches A. I like this form better because I see the change in Y. I see the change in X. I see slope. Because then I can remember it. You will see this in your science classes more so than the other one. You guys like the math ones better, okay, James? Is it different? What can you say here? What's H equal to? H equals what? X minus A. So if you solve for X, what's X equal to? Or you could look in the picture. What's X equal to? A plus H. If you substitute that in there for your X, you're going to get A plus H minus A. And you're going to get F of A plus H. So it's exactly the same thing. Sometimes the algebra is easier with the alternate form. And it's up to you, unless they specifically say which form you want, I don't really care. So let's do the square root of x with this form. So f of x is equal to the square root of x. So I want the slope. It's equal to the limit as x approaches a. Let's see, it's the square root of x minus the square root of a. A could be some number, I don't really care, over x minus a. Do you remember how to do those limits? It hasn't been that long. It's with radicals. Remember those? Remember the trick? Square root of x plus square root of a. Okay, you guys over there? Right? Square root of x plus the square root of a. Now, when you want to cancel, it has to be multiplication. And you're right, I could cancel these factors right here, but then I'm back to where I started. So I've just undone my trick. So instead, let's go ahead and multiply the numerator out, but let's leave the denominator as a multiplication problem, and you will see what happens. What happens when I multiply by the square root of x times the square root of x? Let's just get x. X approaches a, I get x, and then this gives me minus a square root of ax. This gives me plus square root of ax. Do I need to write that down? What's going to happen to those guys? You can't, that's why I chose it that way. These are difference of squares, more or less. And then the last one, so it's minus a all over x minus a square root of x plus square root of a. Now, this really is times 1. Now can I cancel? Yeah. So if you didn't know that before, you should know by now that you cannot cancel or reduce fractions if they're in the form of addition. It's not x going with x, it's x minus a dividing out with x minus a because they're the same numbers. And so now I'm left with the limit as x approaches a of 1 over the square root of x plus the square root of a. Now for the calculus, what do you do next, Sarah? You substitute that in, and you get 1 over. Now if you can't simplify that, that's okay, just leave it. Because if you simplify it wrong, I got to mark it wrong. What is that? 2 square root of a, yes. Especially on the free response, don't simplify. It's really one of the hardest things you're going to run into. Yeah, on the free response. Multiple choice, you'd have to be able to do that. That's fine. No, because on free response, you can just leave it like that. Never simplify on free response. If you're left with the sine of 30 degrees, leave it the sine of 30 degrees. You don't have to evaluate that. Which is nice. Yeah. Okay. We're almost done, actually. We will get to the shortcut. So section 3.3, we need to understand derivatives because what happens on the exam is you may be given this part right here, and you're saying, I don't want to do that limit. You go, oh, wait a minute, I recognize it's the derivative of the square root. And you'll know how to do that when I teach it to you. And you'll do it that way because it's faster, especially if you're looking for the derivative of the sine function. Because remember, on the derivative of the sine function, I had to know that. But you'll eventually learn what the derivative of the sine function is. So no problem. What you have to do is practice with this so that you recognize it. Now, it's been a long time since they've had the definition of a derivative on a free response question. But that doesn't mean it won't happen. It just might. Okay, the last thing is the notation. Your favorite notation is going to be the very first one, y prime, because it's easy. Another way you can write it, if y is equal to f of x, is f prime. But there's a problem with that notation. Because remember, when we do a slope, you have to talk about how something changes as something else changes. If I take a line here, and I do the slope, if I change x by 1, y changes by 1, of course, on my line. And if I change x by 1, y changes by 1. It's always the same, isn't it? Declan? It's always the same, right? Is it Declan? I'll say it right when it says. What about a parabola? Now notice, I have to talk about how does y change if I change x. That's really critical. I'm going to say that over and over again until we get it. Now if I change x by 1, y goes up that amount. What if I go over 1 here? Has the y changed? Yeah. But you have to talk about how the y changes as you change the x value. Another example of that is, let's say I'm blowing up a balloon, which is a perfect sphere. Here's my balloon. Does anybody know the formula for volume? It's 4/3 pi r cubed. So I could talk about how the volume changes as the radius changes. So if the radius changes a little bit, right, what happens to the volume? If the radius increases, what happens to the volume? It increases. So you're talking about how the volume changes as radius changes. Could you talk about how the volume changes as time changes? Blowing up a balloon, sure you could. After 5 seconds, the balloon has a certain amount of volume. So you have to talk about how something changes as something else changes. That is critical to really going on. But I'll be working with you all the time on that to understand a slope is a ratio, it's a rate of change. It's a change in your function divided by your change in your input. Could be time, it could be x, it could be the radius. So it's always a ratio. So we always have to think about that in terms of words, and when you interpret it, we have to do that. So y prime, unfortunately, doesn't tell me how y changes as what changes. I don't know. It's always implied to be x if you use y prime. You'll like it better. It's just short, easy to do. I prefer the dy dx. This is from Leibniz. And this tells me that x is changing. I want to find out how y is changing. We say the words dy dx. It's not really fair to you say that because it leads you to believe it's something where d dx really is an operator. That's the problem with it. So the correct way to say that this is the derivative of y with respect to x. We will say dy dx because it's easier to say, but it's really not correct. We all say it. Names both the variables, and uses the d for the derivative. It's an operator. Yeah, James is here. Okay. Now, it could be the derivative of f with respect to x, or d dx. So it's an operator. So when you find the derivative, you're finding the slope of the tangent line. That's all you're doing. So when I ask you to add 2 plus 3, this is the operator versus 2 times 3 versus 2 to the third power. Those are all operators. They tell you what to do with the 2 and the 3. Here I'm adding, here I'm multiplying, here I'm cubing. When I see this little d dx, I'm going to find the derivative. I'm going to find the slope of the tangent line. That's what it's telling you to do. When we go to the other end, when we do integrals, it'll look like this. Literally, it looks kind of like an S. There's reasons for that. And that's all there is in this section. So tomorrow there is no lesson. It's tomorrow's question answer day. So today, we can look at problem 9 together, or I could just wait and let you try it on your own. But the thing with 9 would be nice is to see what it's doing. Now, everybody should have a book. I do have an electronic version up online. So I wouldn't read it on your iPhone. I don't think that's going to be real good. And so we are on page 134. Then I'm going to give you time to work the rest of the hour. And the directions, I like this book, except I would have done C first. Plot the graph of the function and then draw the tangent line. It is page 134. And also, I like pictures. That's just a bunch of letters. The advantage is you guys grasp letters pretty well, but a lot of people don't. So if we drew a picture of this, it would really help. And we should know what this looks like, right? It's a what? You know what that looks like. It's a parabola, right? But it's not a parabola at the origin. It's where? It's shifted down 5. So I'm not real accurate here. Now, they expect you to be able to sketch it. So if you want to check it with a graphing calculator, fine. But that's not the point. Then I'm going to go to 3, 4, which my guess is up here. And I'm going to draw my tangent line. Okay, I've been teaching slope for a long time, and I finally figured out students don't understand what slope is because they just don't know what it is. It's a number that represents how steep a curve is. So if you have an 18% grade, it tells you how steep that road is. So slope, if I say we have a slope of 1, what's my angle there? Slope is the same as the tangent. These have to be the same. So that's a slope of 1. So if you have a slope of 2, it's getting really steep. If you have a slope of 1/2, it's going down here. It's, it's an arbitrary number, just like temperature. It's going to be 80 degrees today. Well, why did they make that 80? Why did they make 212 boiling? Why is 32 the freezing point of water? Because it's arbitrary. Somebody said, that's what I'm going to make it to be. And I would be interested in the history on that. Where the Celsius makes much more sense. Freezing point of water is 0. Boiling point of water is 100. Okay, so all slope is a number that measures how steep something is. That's it. Okay, look at this one. I'm going to tell you right now that the slope of that is going to be 6. Because the derivative of this is going to be 2x. Some of you know what I'm doing to get that. Some of you think I memorized it. No, I didn't. I hadn't even looked at this problem until last hour. Okay, so we're going to try and find the slope of that. 6 is really steep. Look at 2. If 2 is this steep, 6 is going to be almost vertical. So if you have a slope of 100, I would consider that infinite. Might have run into that. Which form of the derivative would you like to do here? So first I graphed it. Then it says find the slope. You probably like this one, f of x plus h minus f of x all over h, as h goes to 0. Okay, so you guys should do it with me. Is your homework problem? But you should put your homework on another piece of paper. You don't have enough room in that book to write it. You have answers to all the odds. Solutions will be going up. They're done for the first 3 sections, I think. They'll be going up online today, once I get a chance to do it. Okay, so in place of x, I'm going to put in x plus h. So it's x plus h squared minus 5. I lost the 5 earlier today because it's easy to do. There, it's f of x plus h minus f of x, which is, do I need parentheses? Yes, I do. Anytime you substitute in, you really need parentheses. And it's not going to work if you don't. Hey, Jack? What am I going to do with this now? What's the only thing you can think of to do? Math tells you what to do. If you put 0 in, you're going to get 0 over 0. It's begging me to do this. Square out x plus h. Because there's nothing else I can do. So let's do it. And this should be within reason. Now, if you have x plus h to the 8th, you're not going to want to do it. And neither am I. So we'll have to find another way to do these. Because what do you do with e to the x? That's another one. X squared plus, what's the middle term? Even if I do it wrong, I'm going to get it. Well, no, I'm not. 2xh plus h squared minus 5. That's the first one. Oops, 5. Minus x squared minus 5. If you remember, I promised you things would cancel all over h. And maybe it's easier just to look at it here. What's going to cancel here? X squared, right? And what else? The 5s. If you don't have the parentheses there, those 5s will not cancel. That's 0, right? So it's the limit. Remember, I said we should get 2x, right? Then it's 2xh plus h squared. That's it, right? All over h. That's the part you guys don't like, isn't it? the algebra, isn't it? I love the algebra. Factor out an H. Now, at the end of the year, I want you to look back and think of all the algebra you've learned this year. You've truly learned it. So it's H, it's 2x plus H. And that's why you have to do your homework, so you master it. You can't do it once. Okay, Brian? What happens? What cancels now? Riley, what cancels now? H's. Now for the calculus. Ta-da! What's H? It's 0. The answer is 2x. Now, at the point 3, 4, what is the slope? It's 2 times the x-coordinate. Remember, as we went around the curve, well, let's go back up here. What's the slope at the bottom? And x is 0, so the slope is 2 times 0, which is 0. So this is getting steeper and steeper. What's the slope at 3 when x is 3? It's 6. It's 2 times x. Now, do not use y equals mx plus b. We have to write the equation of the tangent line. So I'm going to do y minus y1 equals mx minus x1. Because I want this to be easy. I don't want it to be hard. Y equals mx plus b is hard. So it's y minus, what's the y coordinate? Yes. Because it's 2 times x, and my x was 3. So it's 2 times your x coordinate. So what's my y value, Brian? 4. What's my slope? 6. X minus 3. I'm done. If you do y equals mx plus b, you got at least 4 more lines, and this is a timed test. Do not use y equals mx plus b. You need it in stats. I'm not going to say you don't, but not here. If you want to solve for y because you want to put it on your calculator, I would add 4 to both sides. So I would get 4 plus 6 times x minus 3. That form I could change into y equals mx plus b pretty easily. If I have fractions, maybe not so much, but this sets the stage for Calc 2. Yes. Yeah, don't make things hard. All the answers we're going to give you are going to be in point slope. I don't know how the answer to the back of the book is. Oh, I mean, this one or this one, they're the same. Yeah. And that's it. I could do another problem, but I think you guys want to meet with your groups for a little bit. And I need to get your derivative labs today.
Sine of a plus b equals
Yeah.